Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to solve a system of nonlinear equations by using a couple of strategies together. First, I'm going to use elimination to eliminate the x squared and y squared terms. Then I'm going to use substitution. If you notice that both the top and the bottom equations have positive x squared and positive y squared, if I multiply the bottom one by -1, I'll be able to eliminate both of those squared variables. So copy over the first one, x squared plus xy plus y squared equals 21. Multiply the bottom one by -1, negative x squared plus xy minus y squared equals -9. We eliminate the x squareds and y squareds, and we have 2xy equals 12. If we divide through by 2, we get xy equals 6. So y is the same as 6 over x. Now we can substitute that expression for y in either equation. I'm going to use the top equation. So I'm going to take x squared plus xy plus y squared equals 21. And I'm going to replace each y by 6 over x. X squared plus x times 6 over x plus 6 over x squared equals 21. Simplifying, we get x squared plus 6, because the x's divide out, plus 36 over x squared equals 21. Now I'd like to clear the fractions, so I'm going to multiply both sides by x squared. X squared times x squared is x to the 4th. Six times x squared is 6x squared, plus 36 over x squared times x squared clears that fraction, that's just 36, equals 21x squared. And if I subtract over the 21x squared, I can see that the resulting equation, x to the 4th minus 15x squared plus 36, is quadratic in form. And we can factor this as x squared minus 3 times x squared minus 12. And so x squared is either equal to 3 or 12. And that means that x is plus or minus root 3 or plus or minus 2 root 3. Because the square root of 12, we know that 12 is 4 times 3, and the square root of 4 we know is 2. When we go back to the other equation, even though we're going to need these values of x, it's helpful to remember what the values of x squared were as well. Right. Coming back over to the expression we used to make the substitution, y equals 6 over x. If x is root 3, then y equals 6 over root 3. We can rationalize the denominator by multiplying top and bottom by root 3. That's 6 root 3 over 3, or 2 root 3. When we use x is negative root 3, same thing is going to happen, except the y value will be negative. We'll have 6 over negative root 3, so it's the same expression except for the negative sign, so the result must be the same except for the negative sign. When x is 2 root 3, y is 6 over 2 root 3. Multiply top and bottom by root 3 again. And we end up with 6 root 3 over 2 times 3, which is 6 root 3 over 6, which is just root 3. And when we use negative 2 root 3, same thing is going to happen. When x is negative 2 root 3, y will be negative root 3. So we have 4 potential solutions here Let me collect them all in one row here at the bottom. When we used root 3 for x, we got 2 root 3 for y. Negative root 3 brought us negative 2 root 3 for y. 2 root 3 for x brought us root 3 for y. And negative 2 root 3 for x brought us negative root 3 for y. There are the 4 potential solutions, but we do want to check them. And the equation that we need to check them in is the one that we haven't used yet. We used the first equation to find those 4 solutions. Now we should use the second equation to check them. So the equation we're checking is x squared minus xy plus y squared equals 9. Let's just verify if that's what we have. And so, a couple of things to keep in mind. Root 3, when we square it, is 3. 2 root 3, when we square it, is 4 times 3, or 12. We can see we're going to have to square that, one of those two, or both of them actually, each time. So it's good to remember what that is. Let's start with the first solution, root 3, 2 root 3. Root 3 squared minus root 3 times 2 root 3 plus 2 root 3 squared. Does that equal 9? Well, we know from before what we just wrote down. Root 3 squared is 3 minus root 3 times 2 root 3 is 2 root 9, or 2 times 3, that is 6. Plus, we talked about this a moment ago, but 2 root 3 squared is 12. Does that equal 9? It does, because this is the same as 15 minus 6. So the first solution checks. The second solution, when we substitute those in, the first term is not going to be any different. It's still going to be positive, and the third term is going to be positive. But in the middle, we're going to now multiply 2 negative numbers together, which will make a positive number that we subtract. We'll get the same exact thing. I'll check this in a slightly different color. Negative root 3 squared minus negative root 3 times negative 2 root 3 plus negative 2 root 3 squared. Does that equal 9? And again, that's 3 minus 6 plus 12, just like the last one, and it does equal 9. I'm not going to check the last two, but they are all good as well. All we're doing there is we're switching x and y from the first two, and all the arithmetic will be exactly the same. So all 4 of these are valid solutions. So quick reminder, we use substitution first to get rid of x squared and y squared to produce an equation that we could use in substitution, and we solve the rest by substitution. I'll see you in the next video.